I will start the session. So let me share my screen. So I hope all of you can see my screen.
Yes, we can.
Yeah.
Yes.
Once again, thank you so much for joining with Albedo Foundation's webinar on Python for data analysis and data visualization. So in this webinar, we are going to get answers for few questions like why to use the programming language, and then what are all different programming languages available to use, and why specifically Python for the beginners, and then applications of Python and data analysis with Python, then data visualization with Python, and Python especially for the geospatial applications. So in past few years back, it was very difficult to get data for our modeling in any of the domain. For example, if you want to get the climate data for the past few years, or temperature data, or any other groundwater level data, or any other data regarding any field like GIS field or agriculture field or any other field, it was very difficult to get the input data for our modeling. But nowadays, with the improved technologies, we are getting bunch of information to model, to include in our models. But the only issue is which data should we use for our model, which data suits for our model. So it depends on the data quality. And if you want to know the data quality, we have to gather all the information, and we have to check the quality of the data. That means we have to compare many data sets to use for our modeling purpose. But if you want to analyze these many data sets, if you want to do it manually, how much time it take? Imagine it will take too much of time if you want to just work with the Excel sheet, or if you want to just work with the GIS softwares like QGIS or ArcGIS. It takes quite hell of time, and there will be more chances of errors if we are doing manually for longer duration. So we may lose the concentration and we may do too many mistakes. So programming helps to work smartly and effectively. So it can reduce our efforts, manual efforts, and it can also do our work fast without taking much time. And programming also develops the logical thinking. So for example, uh, if you want to do any task, then you don't need to do in one way, you can do it in several ways. So for example, if you want to compute the correlation between two data sets, then you can directly use the correlation formula in Excel sheet, or you can use the correlation formula directly, or you can calculate one by one. So the variable value minus mean of the variable, then sum of squares of those variables, and divide with the sample size and all. So there will be many ways to solve each problem. So if we use programming language, we can think logically how fast we can do this task. And then not only about our logical thinking and smart way of working, so regarding the career prospect, so there will be too many opportunities by using the programming language. So if you just open the LinkedIn and check for any job, so 95% of the jobs which posts in LinkedIn, so they need the programming. It's not only Python, so you have to have at least one programming knowledge to apply for any job, 95% of the jobs in LinkedIn. And so programming also can lead to high income potential. So if you have very good programming knowledge, so you can demand as much as you want. So there are several programming languages available. So few of them are like noted programming languages are Python, Java, C, C++, R, MATLAB. and many other programming languages. Out of these programming languages, for the beginners and even for the advanced level, Python is the best. So based on few surveys, so in the first plot we can see, so popularity of the programming language ranking in 2020. So this analysis is from the agency called Devtan. So they have taken the popularity programming languages in percentage, and they have given around 30% to 30% of the popularities to Python programming languages. That means 30% of the people usually use Python programming language. And there is another survey which is based on the LinkedIn job postings in the USA and European region. And they have mentioned that Python is the most popular programming language to get the job opportunities. And if you see the third plot, in which they have given the average salary we can get if we know the programming language. So Python is in the third place, and on an average per annum we can get around $1 lakh if we are good in the Python programming knowledge. So that is the importance of the programming. If we know the programming, then we can do whatever we want. So the programming language is not limited to any specific domain. So you can use the programming language in civil engineering, mechanical engineering domain, electrical engineering, IT, agriculture, GIS, chemistry, physics, mathematics. So here in this webinar, I am going to give only few examples. So what you have to do, you can correlate whatever the examples I am showing you in this webinar with your real-time problems. So for example, now I am going to show you a groundwater data. So in Indian region, I have taken 500 locations groundwater level information, and now I want to analyze these 500 kgs groundwater level information.
Slides are not changing.
Hello, sorry, can you hear me clearly?
Actually, slides are not changing.
Actually, sir,
So now I have 500 groundwater level gauges, and I want to analyze the information in which locations the groundwater level is depleting. So if I don't know programming language, for each location, I have to open the Excel sheet, and I have to see how I have to analyze the data for last 10 years, from 2010 to 2022, how groundwater levels are depleting or how groundwater levels are increasing. And I have to note down in separate Excel sheet to see whether the groundwater level is increasing or decreasing in that particular location. And I have to do the same task 500 times for 500 locations. If I know programming language, I can just write a program within half an hour to handle one station, and I can input all these 500 stations for my programming, and I can get the results. Not only just whether the groundwater level is increasing or decreasing, I can get the plots, how groundwater level is increasing in the intermediate period and how it is depleting in the recent periods. And I can also correlate the increase in groundwater level or decreasing the groundwater level with the precipitation data, or how increasing temperature is influencing the groundwater level data. So I am just giving the example how we can use the programming language for groundwater level data, and you can correlate the data corresponding to your domain, and how I can use the programming language effectively to do my tasks easily. And so few of the examples of using the Python programming is, Python is the best programming language to learn first because it is easy to use. So if you see the Python commands, they are more or like English sentences. So you can easily, for example, if I write any programming in Python, and if I give to you, and just by reading the lines you can understand the programming and what I am doing in the programming, because it's very handy and it's very easy to read, and it follows the English sentences only. So for example, if I want to get the mean of time series, the command is just the mean. And if I want to get the length of the lines within a text file, then the command is just length. And if I want to get the minimum of the time series, then the command is min. So it's the syntax is very similar to English language. That's why it's very easy to learn the Python programming. And it can be the Python programming can be run anywhere, including Windows, Linux, and Mac OS. And there is a big community for the Python programmers with lot many conferences and magazines. The Python programming is created early 90s by Guido from Netherlands. And the name Python comes from Monty Python. It's not came from snake. So there are many other platforms within the Python. They are like Anaconda, Spider. So these platforms are coming with built-in modules. And then there are many web platforms like YouTube, Instagram, Pinterest, uh, and several web platforms. They are built using the Python programming knowledge. So there are several applications using Python. So here I am going to just show you few applications of the Python. And it's very important for any domain, for any field, to learn the programming language. And Python is the best to start with, because it's easy to understand. And familiar with the once you are familiar with one programming language, it's very easy to switch to any other programming language. So what you have to know exactly from programming languages, you have to know how syntax is working. That means how for loop is working, how if condition is working, and then how we can use the while loop. And within the loop, what is happening, we have to know exactly what is happening within the functions. Once you get to know these things, it's very easy to use any kind of programming language. For example, you may give the interview and you got selected, and after going into the organization, they might be using other programming language. You are mastery in Python, and they might be using other programming language like MATLAB, or any Fortran C. But if you have good grip on Python programming language, it's very easy for you to switch to another programming language, because you already know what is happening within the loop, or what is happening if the if condition, and how to use 3 or 4 conditions to print any value. So if you know Python, then it's very easy to switch into other programming languages as well. So here I am going to show few applications of Python in order. So for example, we want to develop any model. So let's say we are going to develop climate model. So to develop climate model, we need few parameters like precipitation, temperature data, and all. So uh, I want to collect the temperature data. So there is a temperature data available from the Indian Meteorological Department. So those files are available in the yearly format. So there will be a one net CDF file for each year. And if I want to download each file manually, and the data is available from 1900 to 2022. So it's around 123 years of data. So if I want to download each file manually, I have to go to the website, and I have to click on each year, and then select the file, and I have to download the file. So that means I have to do the same task 123 times. So 123 times I have to do the same task. And if we are doing the same task repeatedly, there are many chances to get the error. We may miss few years in between, and we may download, we may duplicate the years or files. So instead of that, there is a option called web scroller in Python, using few modules like Selenium, Beautiful Soup, and there are other libraries like urllib. So we can use these libraries, and we can automate the process to download all the files at a time. That means we take the URL corresponding to the all these files, and we can write a program to download all these files at once. So once we can automate this process, within a minute we can get all these files. And once we get these files, now you want to use these files for your modeling purpose. And if you want to use the data from 1900 to 2022, and each year information in separate is in separate file, then it's difficult for you to use. You have to open the file, you have to analyze the data, or you have to get the data from there and you have to paste in Excel sheet, then open the second file 1901 year file, and then uh, copy the data, paste in the Excel sheet. So if you want to do it the same, you have to do it 123 times, and it will take quite hell of time. So just to process the data, you will need 3 or 4 months to download, to process, and everything. So if you know the programming language, what you can do, you can scroll the data, you can download the data, and then you can process the data. You can just combine the data from all these 123 files in 10 minutes using the programming language. And if the data is properly formatted, that is fine. In the next step, so for example, I have downloaded the gauge data corresponding to one gauge. So this is the gauge data that I have downloaded. So that data looks very similar to this data. So can you see my Excel sheet?
Yes,
Yes, sir.
Yes.
Yeah. So for example, I have downloaded the information of one river gauge information, where I can get the flow in the river and then water level in the river. So the data is in this format. So the data for the first year 1987, 1988. So this is a Q, and Q, that is the flow, and this is a water level information from June to May. And if you see, the data is not consistent. There are no data values in between. And if they don't collect the information, they may give some negative values. Or if they are entering manually, there may be too many errors within the data, and we don't know whether the data is consistent or not. So they may miss 1 year after 1988, 89. They may miss 1 year and they can give some other year. And if I just want to use this data, I can't directly use this Excel sheet into our model, into my model. I have to clean the data in such a way that it should be in the time series format. So it should be something like this. So we should have the date, and we should have the corresponding flow information, and we should have the corresponding water level information. So imagine if you don't know programming language and you want to clean this file. So every time what you have to do, you have to copy this information from Q corresponding to this month, and corresponding to June for the first year 1987, 88, and you have to paste in the separate page. And then again you have to copy other information, you have to paste. So if you want to do it for 30 years, imagine how much time it takes. And you don't know whether the data is consistent or not. So uh, after 10 years, they will miss 2 years, and they are continuing with the third year. Then it's very difficult to check all these things manually. And if you know the programming language, and if you just write a script to convert this type of format to time series format, something like this, and even if you get uh, hundreds of similar files like this, and you can convert all of them within few minutes into the time series format. And here you can also check whether the data is consistent or not, or you can just check if there are any negative values, or if there are any high values. For example, they may keep, instead of 3000 meter cube per second flow, they may keep 10 extra. That will become 30,000 meter cube per second, which is a impossible thing. And once we get the plot of this time series, we can get to know all these things. So that is the advantage of using programming language. So it make our life very easy to process any kind of information. So we don't need to keep so much of time just on the processing of the data. We can keep most of our time to get the innovative things. Once we have the data handy in the right format, it's very easy for us to develop any model, or to do any kind of tests with the existing data. And then there are several other applications also using Python. So we have a so as I mentioned, we have a 500 gauges groundwater level data, and I want to check what is the minimum, maximum, mean, standard deviation, variance, correlation, coefficient. So I want to see the correlation of the uh, groundwater level data between two states. So for example, Madhya Pradesh and Rajasthan, how groundwater levels are depleting in Rajasthan with respect to Madhya Pradesh. So if you want to get these correlations, we don't need to all the time go to Excel sheet, write a formula, get the information. So instead of that, you can read the file directly from program, and then you can correlate between the two states, read the information from one state, from MP, read the information from Rajasthan, and just get the correlation. That much simple if we know the programming language. And you want to know what is the maximum one day precipitation in a year from the last 50 years. So you can easily get the time series data from precipitation, and you can calculate the minimum, maximum, mean, standard deviation, and whatever you want. So, and many of us, whatever domain we are working, so once we calibrate the model, and once we set up the model, we usually check the statistical parameters like R square, RMSC. RMSC is nothing but root mean square error, and bias, to check how accurate our model, our predicted model. So we can calculate all these statistical parameters within a line using Python programming language. And if you want to fit a linear regression between two data sets, so we can easily do the task in Python. And if you want to do any significance test, so for example, we are correlating two things, that is amount of precipitation and groundwater level increasing or decreasing. So we want to see the correlation significance, whether increase in precipitation is increasing the groundwater level or not, or uh, decreasing the precipitation compared to previous year, whether it is depleting the groundwater level or not, or if we are pumping the water, number of pumps, whether they are whether they are correlating with the groundwater level data or not. So these things we can check the significance of one parameter with respect to another parameter. So if you want to do the significance tests in Excel sheet, it takes too much of time. So if we know the programming language, it's just a matter of one line to get the significance test. So it's just like I am taking the examples from one domain, and you have to uh, correlate these examples with your domain, whatever the input data you have, or whatever the tasks you want to perform, you can correlate with these tasks, and you can perform in the Python. It's not at all limited to any of the domain. So Python can be used in any of the domain, including physics, chemistry, agricultural engineering, or agriculture related crop productivity, and how crop productivity is varying from the last few years. And in the geospatial tasks, we can use the Python. So one more main important thing and important application of Python is the data visualization. So so for example during COVID time, you might have seen how beautiful plots we got. So, and how much information we are gathering through the plots. So we are seeing the worldwide map, and we are seeing the number of cases per day in each country. And these plots are very easy to visualize, and very easy to get the conclusions instead of having the data in the table format. And for example, as I mentioned, we have 500 uh, groundwater level gauges information, and uh, I want to get the time series plot for each gauge location. So if I want to do it, I have to do it 500 times in the Excel sheet. For each gauge, I have to open the Excel sheet, and I have to get the line plot, bar plot, or histogram plot, whatever it may be. But if I know the programming language, so I can just write a function to get this plot, and I will input all these 500 gauges for my program. I will get 500 plots within a minute, even in the less than a minute. So how easy it is. And if we do it manually in any of the Excel sheet, then there will be many chances of getting the error. So it's very important to know any of the programming language. And among all other programming languages, Python is the best. It has the best community, and it's open source. We don't need to pay single penny. The only thing is, we have to first learn the programming language. First we have to understand how programming language is working. That first we have to do. Once we learn the basic Python programming and advanced Python programming and Python for GIS, then you can do whatever you want in the programming language. So the thing is, you have to understand how the programming is working, and how I can correlate the programming syntaxes to my domain. That you have to know first. And then, so there are many data visualization options. You can if you want to do, for example, the same temperature information for five important cities of India: Delhi, Hyderabad, Mumbai, Kolkata, and Chennai. I have given the plots in three different formats. The first one is the pie chart, second one is the line plot, and third one is the temperature plot. So even if I have the information from 100 cities, then I can use the same function. So except including 5 cities, I will just include 100 cities. That's the only change I have to do if I know the programming language. And we can do the histogram plot. So in a year, how many days are with temperature greater than 30 degrees centigrade, and how many days are temperature with less than 20 degrees centigrade. These calculations we can do using histogram. And if we have the sales data, then uh, we want to know how many books are sold in the 2022 first quarter, and how many pens sold out in the first quarter of 2022. This information we can directly get in the pictorial format using any programming language. So I may just working with the sales data for pens and books. So some other might be working with some face creams, face wash, and these things. So they can use the same functions. Instead of putting the input data of pens, books, they can just keep the another information. And the same information we can see in the pie chart as well, and we can represent the percent of the sales. And if you want to get the same information in two different plots, so that is also possible in Python. And there are several other options. We can get the interactive plot also. So for example, if I want to get the temperature data corresponding to Hyderabad. Uh, that is visible once I keep the cursor here. That is also we can do using the Seaborn library in Python. So just here I am showing you the basic examples what we can do using the Python programming. Python programming, and we can do several things. Once you get the grip on basic, advanced, and GIS Python GIS programming, you can you can do whatever you want. And once you get the grip on these concepts, it's very easy for you to understand uh, the syntaxes from the Google also. So now you have some command and program, and if you search anything in Google, it's very easy to grab the things. So we can do other plots also. For example, earlier I have shown you the flow gauge information, and here I have a plot of maximum flow information for each year from 1987 to 2016. So if we think there was a manual error, these values will get shoot up, and if there are any negative values, they will get shoot up here. And if you want to do time series plotting, so here I gave the time series plotting of uh, observed flow, simulated flow, and corresponding precipitation on the top axis. So we can do whatever you want. So this is for one region, and if I have multiple regions to have the same plots, I can just change the input data, and the output I will get will be same. So I don't need to all the time repeat the plotting. So just I can change the input data, and I can get the plot for all the locations. So that makes our life very easy. And so one more important applications of Python is the GIS applications. So nowadays we are getting vast of GIS related information. So we are getting shape files information. Uh, for example, we are getting the land use land cover information. Land use land cover information is nothing but we get the uh, classes of land use. That means within if the data resolution is 10 meter, 20 meter, or 30 meter, so it will be within each pixel what is the type of class, whether that is the forest or agriculture land, built up area, or it is a water body. So we are getting too much of information, and we are getting too much of satellite data information, like Sentinel-1, Sentinel-2, Sentinel-3, Sentinel-4, Sentinel and Sentinel-5. So we are getting so much of information, how much vegetation we have, and what is the cloud cover we have, and what is the temperature within the 20 25-kilometer grids, and what is the precipitation within the 25-kilometer grids. And we are having too many shape files, like where we have the healthcare centers within India, and what are the state boundaries, and country level boundaries, then district level boundaries, and taluka level boundaries. So we are getting too many shape files, and now it's our turn to process this data. So Python can read all the GIS vector formats such as a shapefile, SHP, KML format, GDB format, and many other formats. And also, it can read all the other raster formats like GeoTIFF, BRT format, and then image format, and whatever the tasks you can perform using QGIS or ArcGIS, that you can perform in the Python. So the only thing is you have to know the basic Python and advanced Python, and you have to know the Python GIS programming. So these are the few applications, just few applications. I would say 1% of the what we can do in Python GIS programming. So for example, here we have state level boundaries of India and district level boundaries of India. So these block lines are state level boundaries, and red lines are district level boundaries. And the second one is, so how we can separate. So for example, uh, you have your project in which you have to create separate plot by showing number of healthcare centers in each district of each state. So for example, in your project uh, you have to create a number of healthcare centers by district for each state. For Madhya Pradesh, I have separated the districts for Madhya Pradesh state, and then I have given a special plot of how many healthcare centers are within the within each state. So the white color represents less than 10 healthcare centers, and light the light red color, very light red color, that may represent 20 to 30 healthcare centers, and bit of uh, dark red color that can represent 20 to 30 healthcare centers, and the dark red can represent 30 to 100 healthcare centers. So if I want to do the same for all the states in GIS, so all the time I have to select the state, I have to clip the state, and I have to clip the corresponding district boundaries. Then I have to change the plot. So if I know the programming, so I will do it once, and I will use the for loop for each state, get the plot for me. Got it? So this is just basic example I am showing you here. You can imagine and you can connect the same with corresponding to your tasks. So how to get number of districts in each state. So here, if you want to know how many districts are corresponding to each state, we can intersect boundaries of districts with the boundaries of states, and we can count how many districts are corresponding to each state. And then how to separate the district shapefile by state. Just intersect district shapefile and clip clip the districts corresponding to each state, and then how to get the spatial plot with the number of healthcare centers in each district. So once we know the healthcare centers in the point shapefile format, which I will show you in the next slide, then you can have a spatial plot within the Python. You don't need to open the QGIS or ArcGIS. You can just do it using the Python. So this is polygon operation. So one more application of Python is the line operation. So I have a river network corresponding to few states of India. So I have just taken the subset of river network for India. So just to demonstration purpose. And so now how to get river network length in each state. So I want to get the length of river network corresponding to length of river network in the Tamil Nadu state. So what I can do, I can clip the river network with respect to Tamil Nadu state, and then I can calculate the length of river network within that clipped boundary. Okay. So, and then if you want to know the river network density by state, density is nothing but total length of the network divided with total area of the state. So we can do this, we can do both GIS operations and statistics at the same time using programming language. And this is one more vector operation file, that is the point shapefile operation. So here we have the healthcare centers information throughout the India, and we can perform many tasks by using these two data sets, healthcare centers point shapefile. So in fact, the healthcare centers information is in the CSV format. We can easily convert CSV format into shapefile format in the uh, in the GIS. Uh, in the GIS. So for example, if I have healthcare center information by state in CSV format and I want to get it by India, then all the time I have to open Excel sheet and I have to combine all these Excel sheets one by one. So if I know the programming language, I will read all the states CSV files. I will just combine these files within a single line, and then I can convert the single CSV file into shapefile format. Then I can directly overlay on India, and I can get the answer for all these questions. How to get number of healthcare centers by state? I will just intersect point shapefile with each state shape boundary, and I will get the count. And then I can get to know what is the density of healthcare centers by state, and how to calculate the number of healthcare centers by district by overlaying the district shapefile and uh, the healthcare centers point shapefile. Then how to get the nearest healthcare center for your location. So there is a provision to calculate the distance between 2 points in the programming, Python GIS programming. So you can just enter latitude, longitude of your location, and you give the input as a healthcare centers point shapefile, and within a minute you will get the nearest healthcare center to your location. That's the advantage of using programming language. So not only vector file or shapefile operations, there are there are several applications of Python. Uh, so we can do too many raster operations using Python. So for example, uh, if you want to get the land use land cover information, so we have downloaded the land use land cover information corresponding, which may corresponding to uh, 250 square kilometer or 1000 square kilometer area, but we want to have it just for our study area. So loading the land use land cover data with 1000 square kilometer area is too much in the GIS, QGIS or ArcGIS. It's very difficult to visualize the uh, land use land cover data. So what you can simply do, so download the land use land cover data, and whatever the boundary shape file you have, you just clip your land use land cover raster with your boundary, and just delete the 1000 square kilometer of land use land cover data, and visualize the data that you have clipped. And if you want to clip the data for 100 regions, then you can just use the for loop and you can clip. You don't need to open the file each time, and you don't need to clip it in QGIS or ArcGIS 100 times. So it can save your time, and it can increase the accuracy of your work as well. And also, for example, you want to reclassify the data. You have the land use land cover information. So in the land use land cover information, you have lakes information separately, reservoirs information separately, and rivers information separately. But you want all these water bodies information representing with the single pixel value. So you can read the raster in Python. You can convert into array format and replace all these pixel values, like which is corresponding to reservoir, lake, and river, to single value, and save it into the other raster file. There you will have the same class for all these different classes. Okay. And you have a land use land cover data, and you want to know percentage area covered by each class. That is percentage area covered by built up area, percentage area uh, covered by waterways or water bodies, and percentage area covered by forest. So you can easily get all these statistics from the satellite images using Python programming. And also you want to check how much area of the water bodies is are converted into built up areas in the recent periods. So that information also you can easily get from Python programming. And also, if you want to delineate catchments, rivers from the DEM, you can easily do it using Python programming knowledge. And these are only few applications. I am saying it's just like 1% of uh, all the applications. So once you explore all these things, you will get to know how many other applications uh, for how many other applications we can use the Python programming. And this is a sample plot from Vivekananda et al 2020. So where they did the analysis of changes in the land use land cover data. So here in the red color represents the built up area, and the yellow color represents the agricultural area, which is the left side plot is from 1978. And if you see the right plot, which is corresponding to 2018, here you can see how much area of built up area, sorry, agricultural land is converted into built up area, which is representing in the red color. So with statistics, how much area, 10%, 20%, 30% is converted into converted agricultural land into built up area, or water bodies into built up area, or forest into built up area, or forest into agricultural land. These statistics we can get with 100% accuracy using the programming knowledge within the short time span. Okay. And so not only these applications, so not only these applications. So for example, I want to show you few live examples. So here we have the sales data corresponding to region, country, and item type sold, sales information, and total profit information. So if you want to do the analysis using the Excel sheet, it takes too much of time. So for example, just I want to show you few lines. So using the library called pandas, I want to get get what is the total profit, sum of the total profit. So just using 3 lines, I can get it. So I just need to import the module. I just need to read the data from CSV file, and I can just get. So if I just use this line number 49, I can get the total profit corresponding to all the countries. So if you want to do the same in Excel sheet, it takes too much of time. And I want to know what is the minimum profit. So 1258 rupees are the is the minimum profit for particular country, and I want to know which country it is. So I can simply use line number 53, and I can get. So can you see? So the country is from Middle East and North Africa. That is the Kuwait, which has the minimum total profit. And if I want to get maximum profit, I can use the line number 57. So there is a the maximum country with the country with the maximum profit is the Pakistan, and the maximum profit is around around 17 lakhs 19,900 rupees. So this is uh, this is very handy to do all these types of analysis using Python programming knowledge. And one more example is, for example, I have these many locations information, these many subcatchments I have. So let's assume I have uh, 40 locations information. I want to get the return period information for each location. Then I can simply use this programming language. So here I am just giving a loop to compute the return period information for each and every location. So this script just take less than a minute to get the return period information for around 22 locations, and to compute 2-year return period, 5-year return period, 10-year return period, up to 100-year return period. So programming makes our life easy, and it can save our time and also our efforts. So once we save the time in processing the data, then we can keep our time for learning the new things, or to try the new approaches which can improve our knowledge.
है ना, तरीका नहीं है